Do you think the biggest obstacle on the way to Saturn is the enormous distance or its famous rings? What about the fact that this planet doesn't have a solid surface at all? That if you tried to sit on it, you'd sink into an ocean of scorching gas? Today we're setting off on a journey to one of the most beautiful, and at the same time most dangerous, planets in the solar system. You'll find out why Saturn's core temperature reaches nearly 12,000 degrees Celsius, hotter than the surface of the Sun. We'll figure out whether life could exist on its moons, and by the end, you'll understand why it's impossible to fly back home from Saturn, even with the most powerful spacecraft imaginable. Ready to take a look at a world where the laws of physics we know start working against us? Let's begin our journey. First, let's get a sense of just how massive this trip actually is. The distance between Earth and Saturn isn't fixed, since both planets are moving along their own orbits around the Sun. When Saturn is at its closest to Earth, roughly 1.2 billion kilometers separate us. When the planets drift to opposite sides of the Sun, that distance grows even larger. For comparison, the distance to the Moon is only about 384,000 kilometers. And even that already feels colossal to us. That means Saturn sits roughly 3,000 times farther away than the Moon. This isn't just an abstract number. It's a very real obstacle that directly determines how long any trip would take. Even the fastest spacecraft we've ever built needed years to cross that distance. The Cassini probe, for instance, took 7 years to reach Saturn's vicinity, while the legendary Voyager 1, which flew past the planet, took 3 years and 2 months to get there. And those were both uncrewed vehicles. Now imagine what it would mean for an actual human being to spend several years confined inside a spacecraft. Beyond the obvious psychological toll, there is also a very real physiological threat. Extended time in zero gravity leads to muscle atrophy and bone calcium loss, and space radiation has extremely damaging effects on living tissue. But even if we imagine, by some miracle, that we solved all of that and built a ship capable of getting a crew to Saturn in about a year, a new invisible barrier awaits us as we approach: the planet's radiation belts. Inside them sit particles powerful enough to punch straight through spacecraft hulls, damaging electronics and harming living organisms. Earth has its own radiation belts too, and they already pose a real danger to satellites and astronauts. But Saturn's are far more intense. Some of that radiation gets absorbed by Saturn's rings, but nowhere near all of it. Let's suppose, just for a moment, the unlikely. We build a ship with ideal radiation shielding and complete this years-long voyage. Even then, before we get close to the planet, there's one more invisible, but extremely dangerous obstacle to deal with: Saturn's magnetic field. It extends roughly 1 million kilometers toward the Sun and functions as a gigantic trap. Saturn's magnetosphere dwarfs Earth's in scale, and it would easily fry any unshielded electronic equipment. One of the most surprising features of this planet's magnetic field is its near-perfect symmetry. On Earth, the magnetic poles are visibly offset from the geographic ones. On Saturn, the magnetic field's axis lines up almost perfectly with the planet's rotational axis. Scientists believe that strict symmetry is linked to a special layer of helium deep inside the planet that plays a stabilizing role. For a long time, this quirk actually prevented astronomers from precisely determining Saturn's rotation period, since a planet's magnetic field is normally one of the key tools used for that kind of measurement. Only data gathered by the Cassini probe finally helped solve that puzzle. Though understanding the nature of the magnetosphere doesn't make it any less dangerous. Saturn also has a moon called Enceladus that shoots enormous jets of ice into space. Those particles get captured by the magnetic field and accelerated to tremendous speeds, adding yet another hazard for any spacecraft daring enough to approach the planet. But let's imagine we've overcome every one of these obstacles. Do you think landing would go smoothly? Let's find out. Picture our imaginary spacecraft, having cleared every hurdle, finally entering orbit around Saturn. Before us, in all its glory, sits the majestic gas giant with its shimmering ring system. And it's precisely at this moment that we run into the first and most fundamental problem. One that renders all previous effort meaningless. It is physically impossible to land on Saturn in any conventional sense. It simply has no solid surface the way Earth, Mars, or even the Moon does. Saturn is a gas giant made up mostly of hydrogen and helium, with a small amount of methane. Other elements like ammonia and water vapor are present only in trace amounts. Everything visible in photographs of Saturn is just the outer edge of an extremely dense atmosphere, the tops of ammonia clouds, beneath which lies more of that same gas. That gaseous ocean gradually transitions into a dense liquid. Trying to land a spacecraft on Saturn is really the start of an uncontrollable, endless plunge into an abyss. To understand what would happen to any craft that dared to dive into Saturn's atmosphere, let's follow it through that imaginary fall. Let's start with temperature. In the upper layers of the atmosphere, where pressure is still relatively low, a brutal cold reigns. Temperatures here swing between -15 and -139 degrees Celsius, Any equipment would freeze solid almost instantly, and that's only the beginning. As you descend deeper into the planet, both pressure and temperature start climbing rapidly. Saturn's atmosphere is incredibly dynamic, with winds reaching speeds of up to 1,800 kilometers per hour. For comparison, Earth's most destructive hurricanes top out at just over 250 kilometers per hour. On Saturn, though, these supersonic whirlwinds are entirely routine, more than capable of tearing apart any probe before it ever reaches the deeper layers. But what awaits further down, if we somehow made it through the atmosphere? Let's say our remarkable ship survived even that. It keeps sinking, and conditions around it grow ever more extreme. At a depth of about 1,000 kilometers below the visible clouds, temperatures reach around 730 degrees Celsius, hot enough to melt many of the metals we know. The pressure here is so immense that hydrogen, a gas at the surface, transitions into a liquid state, and that's just the start of the journey toward the planet's center. At a depth of roughly 20,000 kilometers, pressure exceeds 1 million atmospheres. To grasp that figure, imagine every square centimeter of your ship's hull bearing a weight comparable to about 1,000 passenger cars. Under that kind of pressure, and at temperatures around 6,000 degrees, hydrogen enters a strange new state entirely. It becomes a liquid metal, similar in its properties to molten lithium. This layer surrounding the planet's core is the source of an extraordinarily powerful magnetic field. The movement of charged particles within this colossal ocean of liquid metal generates electric currents of staggering strength, which in turn produce the magnetosphere. For our imaginary craft, this means only one thing: total destruction. Any material known to us would be crushed and then melted long before ever reaching this region. At the very center of the planet, scientists believe there's a solid core made of iron and nickel surrounded by a layer of heavy elements. Its mass may exceed Earth's by 15 to 30 times. The core temperature reaches nearly 12,000 degrees Celsius, 2.5 times hotter than the surface of the sun. Saturn is hotter on the inside than our own star is on the outside. Any probe entering Saturn's atmosphere would first find itself in a zone of extreme cold, then get battered by ferociously high-speed winds, then get crushed under monstrous pressure, and finally melt at unimaginable temperatures. And do you know what the weather is actually like on this planet? Let's talk about that now. Beyond its obvious physical hazards, Saturn draws attention for an enormous number of myths and mysteries. One of the most intriguing and visually striking is the famous hexagon, a gigantic six-sided formation sitting at the planet's north pole. First discovered back in 1980 by the Voyager probes and later studied in detail by the Cassini mission, this formation is a stable atmospheric vortex with an almost perfectly hexagonal shape. At its center churns an extremely powerful polar hurricane, with wind speeds reaching 320 kilometers per hour and up to 540 kilometers per hour at its core. Winds on Saturn blow twice as fast and 4 times as forcefully as anything on Earth. But the truly surprising part is something else. Hurricanes on Earth are always on the move, driven by atmospheric currents and the planet's rotation. Saturn's hurricane, though, stays locked in place at the North Pole and doesn't move at all. Scientists still don't fully understand what mechanisms sustain this remarkable stability. Research suggests the vortex's roots extend deep into the planet's interior, which helps explain its long-term stability. This atmospheric formation is unique in the entire solar system, though there is at least a partial explanation. The hexagon appears to result from complex processes, essentially a giant standing wave produced by differences in wind speed across various latitudes on the planet. And then there are Saturn's rings, which intrigue people more than almost anything else. It's impossible to talk about Saturn without mentioning its most famous feature: its ring system, the single most recognizable planetary structure anywhere in the solar system. Saturn's rings are flat formations made up of billions of ice particles and space dust, orbiting along the planet's equatorial plane. The main rings are typically labeled with Latin letters in the order they were discovered, with rings A, B, and C being the brightest and most visible. From Earth, they look continuous and solid, but in reality, they're made up of countless individua, all the particles ranging in size from tiny dust grains to blocks of ice as large as a multi-story building. The composition of the rings is fascinating in its own right. More than 90% of them consist of water ice, with small traces of rock and organic compounds giving them their distinctive coloring. The origin of the rings is still debated among scientists. One popular theory suggests they formed from the destruction of a small moon that drifted too close to Saturn and was torn apart by its gravity. It's even been given a provisional name, chrysalis. Another hypothesis holds that the rings are simply leftovers from the primordial cloud out of which the planet itself formed. Either way, their age is estimated at between 100 and 200 million years, which on a cosmic scale is remarkably young. Even so, Saturn's rings aren't just beautiful, they're also extremely dangerous for any spacecraft. Although most of their mass is concentrated in an extremely thin layer, crossing through them without risking collision with a large fragment is essentially impossible. The Cassini probe became the first, and so far only, artificial object to risk flying through the gap between the planet and its rings. Any attempt by a crewed spacecraft to repeat that feat would almost certainly end in disaster. Ice fragments moving at tremendous speed would shred a ship's hull like a sieve within seconds. On top of that, Saturn's rings aren't static or unchanging. Under the gravitational pull of nearby moons, gaps form within them, and some of their material is slowly falling onto Saturn itself. By some estimates, they could disappear entirely within roughly 100 million years. You probably already know Saturn has moons, but could any of them actually support life? That's another popular myth worth addressing. The possibility of life on the planet or its moons. The idea that some kind of balloon-like organisms might float in the upper layers of its atmosphere is a captivating one, but in reality the conditions inside a gas giant's atmosphere are incompatible with any form of life we know of. Scientists' real hope for finding extraterrestrial life in the Saturn system isn't tied to the planet itself, but to its moons. Saturn has an impressive retinue of more than 80 moons, but 2 of them deserve special attention. The first is Titan, nearly twice the size of our moon. What makes it fascinating is its thick atmosphere, made up mostly of nitrogen with a mix of methane. Surface pressure there is about 1.5 times Earth's, and the temperature holds steady around minus 180 degrees Celsius. But the most remarkable part is that Titan has seas, lakes, and rivers, just not filled with water, but with liquid hydrocarbons, methane and ethane. This is the only world we know of besides Earth, with stable liquid on its surface. The second candidate for potential life is Enceladus, a small icy moon only about 500 kilometers across. Despite its modest size, it delivered scientists one of the most significant discoveries in the entire history of space exploration. Through cracks in the icy crust at Enceladus's south pole, massive jets of water vapor and ice particles mixed with organic compounds shoot out into space. These geysers, or cryovolcanoes, point to the existence of a vast liquid saltwater ocean beneath the moon's surface. Studies have shown that Enceladus's ocean may contain every ingredient necessary for life: liquid water, organic material, and a source of energy. That makes this tiny moon of Saturn one of the most promising places in the entire solar system to search for extraterrestrial life. It was precisely because of these discoveries that Cassini's fate was sealed. Scientists worried that once it ran out of fuel, the probe might lose control and accidentally collide with Enceladus or Titan, contaminating them with terrestrial microorganisms that might have survived aboard the spacecraft. So the decision was made to send Cassini plunging into Saturn's atmosphere, where it would certainly burn up. But did exploration of this mysterious planet end there? Over the 13 years it spent in the Saturn system, Cassini revolutionized our understanding of the planet and its surroundings. It beamed back gigabytes of scientific data and hundreds of thousands of images, allowing scientists to study Saturn's atmosphere, rings, and moons in extraordinary detail. But perhaps the most dramatic and thrilling chapter of the mission came in its final months. On April 22, 2017, Cassini began a series of 22 daring passes through the narrow gap between the planet and the inner edge of its rings, a region no spacecraft had ever dared enter before. These passes, dubbed the Grand Finale, delivered unique data on the composition of the upper atmosphere, the structure of the magnetic field, and the mass of the rings. On September 15th of that same year, after executing its final command, Cassini plunged into Saturn's atmosphere at tremendous speed. Atmospheric gases heated the probe to staggering temperatures, turning it into a brilliant meteor that dissolved forever into the depths of the gas giant. Cassini's last signal reached Earth 83 minutes after its destruction. The success of that mission inspired scientists to plan new expeditions to Saturn and its moons. Several promising projects are currently in development. Among them is the Dragonfly mission, which plans to send a rotor-winged aircraft to Titan, capable of moving across the moon's surface to study its atmosphere and terrain. Missions to Enceladus, aimed at collecting samples of its ejected material, are also under discussion. Still, all of these ambitious plans remain in development and won't become reality anytime soon. But here's what's genuinely unsettling. You won't quite believe what's coming next. We've debunked the myths and realized survival on Saturn simply isn't possible. Now it's time for the most important, most astonishing fact of all. Even if we imagine reaching the planet and somehow landing on it, there would be no way back. Do you know why? Saturn is a giant planet. Its mass is 95 times that of Earth, and surface gravity at the visible cloud layer is only slightly higher than Earth's. But the real problem isn't gravity itself, It's something called escape velocity, the minimum speed a spacecraft needs to permanently leave a planet and overcome its gravitational pull. For Earth, escape velocity is roughly 11.2 kilometers per second, which is exactly why launching even small satellites requires massive multi-stage rockets. For Saturn, that figure jumps to 35.5 kilometers per second, 3 times greater than Earth's. Reaching that speed would require a rocket of almost unimaginable power. But the real problem isn't even that. A rocket needs a solid surface to launch from, something to push off against. And on Saturn, that simply doesn't exist. Any spacecraft that enters Saturn's atmosphere is condemned to stay there forever. So there you have it. Together, we've taken a fascinating and at the same time unsettling journey to one of the most astonishing worlds in our solar system. We've learned that Saturn's beauty is deceiving and understood exactly why it's a trap with no way out. But that doesn't mean we should stop dreaming about it or studying it. Quite the opposite. The more we learn about planets like this one, the more clearly we understand just how unique and how fragile our own Earth really is. Research into Saturn continues with the help of telescopes and automated probes, and who knows what other secrets are still waiting to be revealed. Subscribe to our channel so you don't miss new investigations and dives into the universe's most incredible secrets. Plenty of astonishing discoveries still await us, and we'll certainly be setting off on a new journey to uncover them together with you. Until next time.